But sometimes the weather is more than just that. Sometimes it's stronger, violent. The wind becomes a tornado, the rain a hurricane. The Earth's atmosphere, for a moment, makes it uninhabitable. And there is nothing we can do about weather like this but try to predict it, prepare for it, and hope that it never happens here. There is one thing without which the Earth would be a lifeless, naked rock. It's the atmosphere, or more specifically, the bottom 7 miles known as the troposphere. 7 miles high, about 25 times the height of the Empire State Building, the level where most airliners fly, a gassy bubble surrounds a planet 8,000 miles in diameter. And that bubble is saturated with water vapor, millions of gallons of it, about as much as in the Gulf of Mexico. Higher up, among huge ranges of temperature, there are further layers: the stratosphere, the mesosphere, and the thermosphere. All our weather happens in the lowest level, the troposphere. The sun drives our weather by heating the oceans, turning them into cloud, and by turning the clouds into rain. It's water going up and down in constant motion. Meteorologists like Helen Young track this motion and the changes it causes, trying to predict what's going to happen next. It's all about the basic ingredients of weather.
There's 3 things that you need to get weather. And the 3 things are air, you need heat, and you need moisture. Because our atmosphere is really just a giant heat engine transferring all those elements in the air from one place to another.
Everywhere the same basic ingredients are mixing, and what they produce can be a sunny day, a gentle breeze, a shower of rain, or a killer storm. What each day brings to people is a lottery. If it's a day for extreme weather, someone will probably die. Every year, storms kill tens of thousands of people. In the worst years, maybe 500,000. Recently in Venezuela, a violent rainstorm set off mudslides, which buried villages and caused 50,000 deaths. They're tragic, but killer storms aren't new. Towns in medieval Europe were swept away. Millions were killed in vast floods in Asia in the 1800s. And in just 1 century, North America was hit by both drought and blizzards. This is the biggest hitter of all, and something that strikes several times every year. It can be hundreds of miles wide and often last more than a week. Hurricane, typhoon, cyclone. Different names from different languages, all referring to the same churning, murderous mass of waterlogged air, with power equivalent to all the world's nuclear armories. In fact, in World War II, more damage was done to the U.S. Navy by weather than any enemy. In December 1944, the U.S. 3rd Pacific Fleet accidentally sailed into the center of a typhoon off the Philippines. 3 destroyers capsized, 146 planes and 800 men were lost. All tropical cyclones start in the same general areas and in the same seasons, when the ocean has been warmed to at least 80 degrees Fahrenheit. Sometimes they'll pass over cooler water and die out at sea, but as often as not, they slam into seacoasts. Greg Holland studies the power of tropical storms.
A hurricane draws enormous amounts of energy out of the ocean, and it turns that into huge spiralling winds, and the winds grab in towards the centre and spiral up to perhaps 200 miles an hour, and it's those incredible winds that makes the cyclone so powerful.
This huge atmospheric turmoil gets started with simple thunderstorms. It's a study in the transfer of heat. Hot air rises. When the ocean surface is 80 degrees or more, the rising air carries a lot of water vapor with it. But as it rises, the air cools a little, and the vapor turns to droplets, to rain. But that very process releases heat, and this overheated air now rushes to the top of the thundercloud. When that happens, it creates a vacuum underneath, and more wet air whooshes up from the surface of the ocean to replace it. The Earth's rotation causes these vertical winds to spiral around a calm center, the eye. Heat, rain, more heat, wind, more rain. It's like perpetual motion, fueling itself from the warm waters. Hurricanes do stop or slow when they reach land as they run out of fuel, those warm tropical waters, but it takes time. Meanwhile, they hammer coastal communities. Hurricanes and typhoons are the only natural disasters with their own names. One of the biggest and deadliest happened in Central America. It was called Hurricane Mitch. Satellite computer imaging shows Mitch's rain as red. Most of it was right around the eye. It's the rain, the second weapon in a hurricane's armory, that can also do huge damage. These torrents simply washed the land off the mountains. More than 20,000 people died, and the economies of several countries were set back 30 years. But after the wind and then rain, it's the third weapon of a hurricane that is probably the worst.
And perhaps most terrifying is the storm surge. This is when huge areas of the ocean get lifted up, 20, 30, in a really extreme case, maybe even 40 feet, and just inundate the whole area.
The hurricane's sheer wind power drives waves from far out at sea, increasing the high tide by as much as 20 feet. It's not a wall of water, just an immensely high tide. 90% of people killed in hurricanes die in storm surges. But not everyone can just abandon their homes as the sea surges in. Sue Myers and her family took their chances at home in Fort Walton, Florida.
We noticed that the water was up on our sliding glass doors at just like a wolf trying to get in. It was angry, angry water. The glass broke, and the water was ankle deep, and then shin deep, and then knee deep, waist deep.
They moved upstairs, and for the duration of the hurricane and for a few days afterwards, their second story and those of their neighbors were islands.
We couldn't walk down there for 3 or 4 days because the water continued to stand. There was debris everywhere. Big holes were in the walls. There were water lines where the storm surge had come in.
This is the aftermath of a surge of 14 feet above the tide line. That's what happened at Fort Walton. and though the property damage was enormous, no one was killed. Hurricanes can't be stopped, but their movements can be predicted, and people can be warned. Research is so advanced, in fact, that scientists can look right inside some hurricanes. With this computer simulation at Goddard Space Center in Maryland, it's possible to actually manipulate the hurricane's image. By moving the storm with an electronic glove and watching with 3D glasses, scientists can change wind speeds and ocean temperatures and learn what makes a hurricane grow or die. Then when a real hurricane comes along, simple observations can increase warning times. And that's all that can be done. Thunderstorms. Like it or not, every year in the U.S., lightning strikes 40 million times. They too have a season.
Thunderstorms are most common in summer months because you've got that heat from the sun, that extra heat that you find in the summer months. And when you get the heat arriving at the ground, you find the air rising. And as air rises, it cools, it condenses, and it produces what we know as a cloud.
Clouds are just great floating ponds or lakes of water vapor. But what turns a normal cloud into a thunderstorm cloud is another matter.
To get a thunderstorm cloud, you've got to have that development of that cloud increasing all the time to make a bigger and bigger cloud. And thunderstorm clouds are the biggest clouds of all. They can extend up to 30,000, 40,000 feet into the atmosphere in some cases.
As the cloud grows, drops of water and bits of ice knock and rub against each other, generating electricity on a massive scale. Just as in a battery, the electricity organizes itself into opposite poles. One end of the cloud is positive and the other negative. Once like this, the cloud battery discharges, sending out massive sparks. This is lightning. It's 5 times hotter than the sun. It makes the very air explode, which we hear as thunder. The air is full of electrically charged ions, and the lightning passes from one ion to another as if along a wire, giving each bolt a different shape. At first, the bolts may go from cloud to cloud, but as the electricity gets stronger, it must neutralize itself to the ground. It goes for the nearest object, which is usually the highest. It's wrong to say that it never strikes in the same place twice. Something tall can expect a lot of lightning. The Empire State Building gets hit on average 23 times a year. Its lightning conductors, though, take the electricity safely down the building to the ground. There are times in open country when people can be among the tallest objects around, and in the U.S. every year, lightning strikes about 100 of them. It doesn't have to be raining. If you are struck, the chances are that the lightning will leave you shocked and burned, but still alive. That's because the electricity usually just passes over your skin. If the strike is big, it does kill, by getting into the body and stopping the heart. This is a bad idea. 1/4 of all people killed by lightning were standing under a tree at the time. Trees are lightning magnets, and when one is struck, the electricity fizzes off it in all directions. The best place to head is perhaps not the first place you'd think of. It's the car with windows up. The body attracts lightning, yes, but metal also conducts lightning away from anything inside and into the ground. Houses, though, aren't so safe. Every year, dozens of people are struck while inside their homes.
I heard this loud crash, bang, as if it were the sound of a .45 caliber gun. Simultaneously, I saw the flash of a blue-white light come out of the corner of my eye.
The lightning, relayed by a telephone pole and a fuse box, came in sideways, straight through the glass door. Houses, in fact, are festooned with lightning attractors. TV antennas, for instance. Power lines, phone lines, even plumbing can take the lightning to ground. In rare circumstances, lightning can fracture a gas pipe. It was a lightning-sparked gas explosion that set fire to an apartment house in Atlanta. The miracle was that everyone living there got out safely. Atlanta that day was hit by a blitzkrieg of lightning. Due to unusual weather conditions, thousands of bolts shot out of the sky, and buildings burned all over the city. It was all part of the billions of dollars in damages inflicted by clouds that turned themselves into colossal batteries. But thunderstorms can be even more deadly. These piles of rubble were houses until they were hit by the fastest wind on Earth. Tornadoes are the spawn of thunderstorms. They spiral slowly across the landscape, packing wind speeds of up to 300 miles an hour. There are about 1,000 tornadoes a year in the U.S., and on average, 80 people a year die in them. One of the most violent ever known hit Oklahoma City in 1999. In the suburb of Moore, the Carlin family was following the storm on television.
It was getting even bigger and bigger, and I started noticing that it was heading our way.
The easiest thing to say, it's moving from Newcastle to Moore. You should have already taken your tornado precautions in the Moore area, southwest Oklahoma City.
I told my wife, it's time, we've got to go.
The kids were really getting scared because they thought it was basically right there and we weren't going to make it to the shelter in time.
The sky was turning black. The clouds weren't any clouds like I had seen before.
And you could hear the tornado sirens going off and everything else, and all of a sudden you hear this, it's almost like a rolling thunder that just did not want to stop.
The walls started vibrating really heavily. I didn't expect that, and I'd never been in an earthquake or anything like that before, and you could actually feel it coming.
You could hear it breaking up everything and all the debris flying around, and so we kind of turned around the right corner of the shelter and all kind of just hugged each other together and just held on for dear life. And then the next thing we know, the cellar door starts kind of tapping, and the next thing, boom, it's gone.
I could hear the destruction. I could hear everything being torn up, glass broken. I looked up into where the door was, and you could see straight up inside of it. I could see debris flying around. But actually to see one go over you and actually look up inside of it, it gave me a sight that I'll never forget in my life.
One of the most peculiar things about tornadoes is the narrowness of their paths of destruction. This one went through Oklahoma City like a bulldozer, leaving everything intact on both sides. But on its trajectory, killing 41 people, injuring hundreds, and creating $1 billion worth of damage. Scott and Susan Carlin lost everything.
We, walked out of this cellar and it's just like everything's gone. Everything that we've had for 10 years of being married was trashed. It's like, it's just so hard to replace everything.
Tornadoes are as freakish as they are cruel. Texas, Oklahoma, and Kansas are where 1/3 of all American tornadoes are born. Close to Earth, moist breezes off the Gulf of Mexico sweep towards Canada, and very high up, the jet stream barrels down from northwest Canada. Sandwiched between is a layer of dry, warm air from the southwestern deserts. The sun heats the ground and evaporates the water from the Gulf breezes, creating thunderclouds. They rise until they hit a ceiling known as a lid, which keeps the thunderclouds from rising further. But sometimes the clouds build up so much that they burst through the lid, right into the path of the icy jet stream. This is what puts the twist in the twister. At the bottom, the clouds are blowing one way, and at the top, the other. From the ground, you see what's known as a supercell, with a fast spinning center. The spinning lowers the air pressure, sending the supercell's twisting center down from the thundercloud until it touches down. And that's when the trouble starts. That's a tornado. Tornadoes look like they're destroying things by sucking them up, but what they really do is just batter with sheer wind power. And once an object is in the air, it can be lifted into the vortex. It can also be turned into a missile. Lots of otherwise unscathed buildings come out looking like pincushions. A lot of damage could be prevented if houses could be built to withstand the things that tornadoes hurl at them. So engineers at Texas Tech University's Institute for Disaster Research are firing planks at walls. They use a compressed air cannon, and the planks hit pieces of wall at 100 miles an hour. What they've discovered is that walls of wood, brick, and concrete block are all easily punctured. Only reinforced steel deflects the planks. Other disaster scientists are working on better early warning systems. This is Doppler radar, moving radar for moving targets.
If we waited for tornadoes to come to us with a stationary radar, we would get very old waiting for that to happen because they're very, very rare. So what we do is we take the radar to the weather instead of waiting for the weather to come to us.
The system works using the Doppler effect, the phenomenon that makes the siren of an approaching ambulance sound different from one that's going away. All radar is based on echoes, in this case, the echo off a raindrop. Add Doppler and you can tell which way the raindrop is going, and if drops close together are going in different directions, their cloud must be twisting. With different colors depicting the rain's direction and different shades showing wind strength, scientists are able to track emerging storms.
With a Doppler radar, we can map out the wind speeds in the tornado or in a thunderstorm. So we can get a three-dimensional image of how the winds are moving different places in the storm. By knowing those three-dimensional winds, we hope we can understand how the tornadoes form, how some get very strong and some stay very weak, and how they die. We had the Doppler on wheels very, very close to the Oklahoma City tornado when it was very near its peak strength. And we observed winds that were over 300 miles an hour, perhaps 500 kilometers per hour. And that was the highest that anybody has ever directly observed with a radar or on the surface. That doesn't mean that that tornado was stronger than any other tornado. It's just that we were the first ones to get that close and measure the tornado with that much detail.
Here goes the vortex team in front of us. There is a large, violent tornado on the ground.
As with all weather, we can't stop it or divert it. But there is one extreme weather that's welcomed. Monsoon winds bring the world's heaviest rain. There are monsoons in Africa and all over southern Asia, but the Indian monsoons are the biggest. They start with an extreme absence of rain. Summer approaches and India bakes in the sun. Everything south of the Himalayas is dust dry, sweltering under a rising plume of heat.
Because that air's rising, there's got to be something coming in to replace it, and you get the cool breeze blowing over the sea. That sea breeze effect brings in moisture-laden clouds from the ocean, and that brings the wet season that we associate the monsoon with.
Saturated clouds sail in from the ocean and over the coastal mountains. They settle in the low pressure left by the rising heat and let loose. Unlike other extremes of weather, the monsoons are predictable. If you're in India and you're soaked, it must be summer. Life isn't easy during the season of the world's hardest rain, but it does make the crops grow. The catastrophe, in fact, is the occasional year when the monsoons don't come. Eventually, the monsoon winds carry the clouds to the slopes of the Himalayas, where they stop until they're all rained out. This is often the wettest place on Earth, the hill town of Cherrapunji. Its yearly average is 36 feet, the height of a two-story house. Sometimes it's as much as 75 feet. That's almost 5 stories. Often the mountain rivers burst their banks, and all the monsoon rain that didn't fall in the lowlands now comes to them as floodwater. And it really is as high as a house. You might be able to predict when a monsoon will come, but how much rain it will bring is still a matter of luck and the whims of the weather. Heavy rain plus high mountains can mean trouble anywhere in the world. The Alps, steep sides of heavily populated valleys, natural bowls. This is the Swiss town of Brig, at the bottom of one of the Alpine bowls. It's a picture postcard place with magnificent scenery. But in 1993, an enormous rain cloud sailing in low got trapped against that scenery and dumped its full load of water, and the bowl began to fill up. A flash flood is the result of a lot of rain over a large area being funneled into a small area. And what makes a flash flood so destructive is its suddenness. One moment, Brig was normal, if rainy, and the next moment, a giant river was crashing through it at a rate of 10 feet a second. That much water moving that fast is, above all, very, very strong. Not much can resist it. Every car parked on or near the main street was wrecked. Every house and business at ground floor level was gutted. Stephen Shanton's restaurant was full of people at the time.
Within a few minutes, it rose about 2 feet. There were over 100 people with us in the restaurant. We had to evacuate everyone straight into the hotel upstairs.
Rescue helicopters had to pluck people off rooftops and out of trees. They did a good job. In the end, only 2 people were killed. Not only were 800 cars destroyed, but with the water came some 10,000 tons of mud and rocks. And that had to be cleaned up. The water poured off the mountainsides for 12 hours. Cleaning up the damage took months and cost $500 million. The calamity that hit this little Swiss mountain town began hundreds of miles away over the Mediterranean Sea. Usually, the moisture-heavy clouds coming off the sea just push against the Alps and stay there. Sometimes there is enough wind to send them up and over the mountaintops. This might result in nothing worse than some light showers. At other times, there are violent downpours. The question is, how can you know what any particular cloud is going to do to your valley? To figure this out, scientists went up among the clouds for a closer look. It was a $20 million international project to establish once and for all the way to tell a cloud's temperament. With scientists and equipment from all over the world, the intention was to fly right into some of the most violent rainstorms.
The movements of the air towards the Alps is important to understand the dynamics of the storm. Unless you know how much water goes into a cloud, you never know how much will fall out of it at the bottom, so you need this information.
We've just passed point 9, so drop A is coming up in about a minute.
That's good. I have all this.
This was uncomfortable flying, both among the mountains and in the storms. The plane was packed with sensors that could analyze everything going on around it. Once in the clouds, the scientists set out to study the air right down into the valley floors. They dropped weather-sensitive capsules called radiosondes, which analyzed the air all the way down and sent measurements back to the plane. As the radiosondes fell, onboard equipment recorded air temperature, humidity, and wind speed every few seconds for later analysis.
It looks good.
The pilots flew over hundreds of miles of valleys, and for the first time, right into intense mountain storm systems. While some of the scientists were looking at the storms from the inside, others were getting an extra dimension from radar on the ground. A mobile Doppler radar was shipped to the Italian Alps from Oklahoma to follow the movements of the storm's water droplets. The project's two headquarters were in Innsbruck and Milan. Scientists at each site correlated all the measurements seeking answers. Screens showed different air pressures and temperatures, and most importantly, the humidity within the storm. They discovered that the worst storms are the slow ones.
One of the most important findings is that it's not the big storm that's causing all these problems. It can be just ordinary, heavy rain going on for hours and hours on end. Big storms have a tendency to move through an area. They look dramatic, but they have not so much of an effect if they move. Now, the Alps have the effect of locking these storms into place. So even a quite ordinary storm can produce absolutely enormous amounts of rainfall over a small area. And if all that rain comes down into one river, this river is going to go overboard.
Ever since there have been people in the Alps, they've been surviving flash floods, mainly by not living in places that flood too often. But flood-free places are running out. Based on this research, it will at last be possible to more accurately predict flash floods. And not only in the Alps, the principle can apply to all mountains, from the Rockies to the Himalayas. There's no worry with flash floods here. It's Antarctica, with temperatures as low as 80 below in the winter and swept by blizzards. A blizzard is snow blown in a wind at more than 35 miles an hour. Here, the weather is so consistently extreme that it's almost uninhabitable, at least for humans. To live here, you pretty much have to have evolved here. Penguins manage it by laying on thick layers of fat and huddling together for protection. Gradually, the colony will change places, so every penguin has its fair share of time in the cold on the outside of the group. But these aren't normal blizzards.
Antarctica is almost like a desert. It's very dry. You hardly get any snow at all falling during the year.
At its center, there is less rainfall than in the Sahara Desert.
But in Antarctica, what you do get is very cold winds blowing down a hillside, and they can reach really quite extreme strengths. And those very strong winds will whip up the snow that's on the surface and cause blizzard conditions.
Winds here can get up to an incredible 120 miles an hour. But that doesn't mean that habitable places don't get blizzards. Throughout history, they have consistently stunned Americans. This was one of the worst winters ever. The blizzard of 1934 brought paralysis to the eastern United States.
This was the year when record snows blanketed Washington, D.C., a mantle of white that paralyzed the nation's capital. The breath of winter that disrupted affairs along the Potomac was only a harbinger of what the northern states were to feel in the winter of 1934. Niagara Falls was brought almost to a standstill, its mighty roar hushed to a murmur. The temperature hovered at 28 below, and the mighty cataract was a mountain of ice.
Extreme weather is often a story of very strong, conflicting winds. But in 1993, a particularly unusual mix of these winds started a storm that became the worst in living history. Early March in Atlanta, Georgia, is a time of year when people are looking forward to summer. But that year, the city, which seldom has snow, was hit by a blizzard of polar proportions. It came right in the middle of what had started as a normal spring day. People were stranded in offices. Some who tried to get home were marooned on the freeway. People froze in their homes when power failed. The blizzard raced northwards up the coast, hitting New York with gale-force winds that blew windows out of skyscrapers. The storm, which dropped 40 million tons of snow over a 2,000-mile stretch, even caught forecasters by surprise. Predicting precipitation is possible, but forecasting what will hit the ground is not.
The air above the Earth doesn't necessarily have the same temperature profile. You can have bands of areas in the atmosphere going up above the ground that are different. So you might have a very cold layer at the surface. You might then find you've got a warmer layer above that. Any precipitation falling out of that will melt in that warmer layer, and then as it comes down into the colder layer again, actually begin to freeze again. And it depends exactly when that happens as to what you find falling at the surface.
Rain will freeze into sleet during a long journey in cold air, and snow falling through cold air onto cold ground will settle as snow. Ice storms are the treacherous result of rain falling onto very cold ground. Large droplets spread out on impact before freezing, coating surfaces with clear ice known as glaze. Ice storms are storms of attrition. This one built up over 2 weeks, gradually encasing everything in heavy, stubborn, deadening ice. Trees collapsed under the sheer weight. Power cables froze, their poles broken. Houses had no light or heat. But what could anybody have done about a storm as bad as this? The answer has remained the same throughout time. The most you can do about the weather is to try to predict it. Many of these instruments are unchanged from the 17th century. In their day, they turned weather recording from an art into science. These instruments that could record a day's temperature, the length of time the sun shines, or the strength of the wind, couldn't make forecasts on their own. But from their accurate measurements, forecasters could eventually show trends, and then, from that, make predictions. A much later generation of instruments on weather buoys and weather balloons can give daily readings and tell a lot more about impending storms and the places they're likely to hit. Since the 1970s, there have been weather satellites. They can see the weather as a whole moving across the planet. Today, there is no chance that a hurricane can strike completely by surprise because of the satellites scanning large areas of weather. The limit of the prediction time for forecasters using them is 3 or 4 days. But now there's something even newer, although a lot about it looks distinctly last generation. It looks, in fact, like a model airplane. But it's actually a robot. It's called an aerosonde, and it could be the biggest advance in weather science since Galileo's thermometer in 1600. It's a simple enough machine powered by a gasoline engine, but an engine that can keep it flying for up to 4 days. and it can go anywhere. It carries miniaturized weather sensors, is piloted by a satellite-linked computer, and flies wherever weathermen want it to fly, no matter how remote or turbulent, sending back every meteorological detail. It has already inspected hurricanes and tornado-generating thunderstorms. One of its inventors is Greg Holland.
We flew into a severe thunderstorm which had a downdraft and very intense winds, which would have brought a normal aircraft out of the air. It kept on flying. Its accelerations were 9 times the force of gravity. Now that would actually kill most people, and the aircraft kept on flying.
It has also done a non-stop flight across the Atlantic on 1.5 gallons of gas. Details about its own performance is part of the information the Aerosonde sends back. With that, operators can make sure it keeps flying. Ultimately, the idea is to send up Aerosondes by the fleet, transmitting such a totality of information to weather computers that every possible storm in the world can be analyzed.
But what the current weather forecast models are able to do is tell us where they need the observations. Unfortunately, they're over the oceans of the Arctic. 4/5 of the planet is where the observations are needed, and there's nothing out there that can take the relevant observations. Imagine 2,000 or 3,000 Aerosondes up in the air being deployed to those areas and bringing back the observations, and suddenly we have a quantum leap in the weather forecasting capacity.
2,000 or 3,000 Aerosondes gathering very detailed weather information could finally break that 3-day barrier in the human ability to predict weather, and of course, extreme weather. Someday it might be possible to know a hurricane or tornado is coming and where it will hit a week or 2 ahead. Then people could really get ready for it. No panicky fleeing or hiding in the cellar while the house blows away. But even so, even with all the new technology, there still won't be any way of stopping the hurricane. This is not to say, though, that humans haven't already affected the weather. Global warming may mean more violent storms.
There's the potential for climate change to make our weather far more extreme. We certainly could see more thunderstorms forming in the future. We could see from that more tornadoes being spawned as well, and we could see more hurricanes forming. It's all quite speculative at the moment, but it certainly does look that our climate is going to be having quite a significant effect on our day-to-day weather as well.
Despite the best predictions, weather disasters will continue to happen, whatever humans do. The Earth is the domain of the sun, the air, the water. There's only one thing we can ever do about weather: try to be ready. But sometimes the weather is more than just that. Sometimes it's stronger, violent. The wind becomes a tornado, the rain a hurricane. The Earth's atmosphere, for a moment, makes it uninhabitable. And there is nothing we can do about weather like this but try to predict it, prepare for it, and hope that it never happens here. There is one thing without which the Earth would be a lifeless, naked rock. It's the atmosphere, or more specifically, the bottom 7 miles known as the troposphere. 7 miles high, about 25 times the height of the Empire State Building, the level where most airliners fly, a gassy bubble surrounds a planet 8,000 miles in diameter. And that bubble is saturated with water vapor, millions of gallons of it, about as much as in the Gulf of Mexico. Higher up, among huge ranges of temperature, there are further layers: the stratosphere, the mesosphere, and the thermosphere. All our weather happens in the lowest level, the troposphere. The sun drives our weather by heating the oceans, turning them into cloud, and by turning the clouds into rain. It's water going up and down in constant motion. Meteorologists like Helen Young track this motion and the changes it causes, trying to predict what's going to happen next. It's all about the basic ingredients of weather.
There's 3 things that you need to get weather. And the 3 things are air, you need heat, and you need moisture. Because our atmosphere is really just a giant heat engine transferring all those elements in the air from one place to another.
Everywhere, the same basic ingredients are mixing, and what they produce can be a sunny day, a gentle breeze, a shower of rain, or a killer storm. What each day brings to people is a lottery. If it's a day for extreme weather, someone will probably die. Every year, storms kill tens of thousands of people. In the worst years, maybe 500,000. Recently in Venezuela, a violent rainstorm set off mudslides, which buried villages and caused 50,000 deaths. They're tragic, but killer storms aren't new. Towns in medieval Europe were swept away. Millions were killed in vast floods in Asia in the 1800s. And in just 1 century, North America was hit by both drought and they slam into seacoasts. Greg Holland studies the power of tropical storms.
A hurricane draws enormous amounts of energy out of the ocean, and it turns that into huge spiraling winds, and the winds grab in towards the centre and spiral up to perhaps 200 miles an hour, and it's those incredible winds that makes the cyclone so powerful.
This huge atmospheric turmoil gets started with simple thunderstorms. It's a study in the transfer of heat. Hot air rises. When the ocean surface is 80 degrees or more, the rising air carries a lot of water vapor with it. But as it rises, the air cools a little, and the vapor turns to droplets, to rain. But that very process releases heat, and this overheated air now rushes to the top of the thundercloud. When that happens, it creates a vacuum underneath, and more wet air whooshes up from the surface of the ocean to replace it. The Earth's rotation causes these vertical winds to spiral around a calm center, the eye. Heat, rain, more heat, wind, blizzards. This is the biggest hitter of all, and something that strikes several times every year. It can be hundreds of miles wide and often last more than a week. Hurricane, typhoon, cyclone. Different names from different languages, all referring to the same churning, murderous mass of waterlogged air, with power equivalent to all the world's nuclear armories. In fact, in World War II, more damage was done to the U.S. Navy by weather than any enemy. In December 1944, the U.S. 3rd Pacific Fleet accidentally sailed into the center of a typhoon off the Philippines. 3 destroyers capsized, 146 planes and 800 men were lost. All tropical cyclones start in the same general areas and in the same seasons, when the ocean has been warmed to at least 80 degrees Fahrenheit. Sometimes they'll pass over cooler water and die out at sea, but as often as not,